Hi friends, my name is Maruti and I'm the co-founder of Cracku. In this video, I'll be explaining the important formulas with respect to modulus of numbers, and I'll also answer 4 questions which are based on that particular topic so that you can understand it better. Let us first get started. Let us first look at the formulas. In this formula, let us first try to understand what exactly is modulus. The modulus of a number gives the absolute value of that number. That is, if it is a positive number, the same number is returned. But if it is a negative number, the positive value of that number is returned. That is, the value of modulus of 5 is equal to 5. But the value of modulus of minus 5 is also equal to 5. That is, the negative value is removed and a positive value is returned. Similarly, the value of modulus of 3 will be 3. And the value of modulus of minus 3 is also equal to 3. A negative number becomes a positive number when you put the modulus on it. Now, if you are given two real numbers, A and B, A can be positive or negative, B can be positive or negative. But what we know is that modulus of A plus modulus of B, that is, if you are individually taking the modulus, this is greater than or equal to modulus of A plus B. This is also intuitive for you to understand. If say B is negative or if say A is negative, then A plus B will be actually lesser. The modulus will be lesser as compared to modulus of A plus modulus of B. To understand this, let us assume that A is equal to 5 and B is equal to minus 2. That is, one of them is negative and the other one is positive. Then the value of A plus B is equal to 3. And the value of modulus of A plus B is equal to 3. But the value of modulus of A is 5. The value of modulus of B is 2. And the sum of modulus of A plus modulus of B will be 7, which is greater than 3. So modulus of A plus modulus of B is always greater than or equal to modulus of A plus B. In fact, if you want to understand this more intuitively, this equality will occur if A and B are either both positive or both negative. In that case, the equality will occur, and it will be greater if one of them is positive and one of them is negative, like we have just described. Anyway, just remember that modulus of A plus modulus of B, that is individually if you are summing them up, is greater than modulus of A plus B. That is, if you are taking the sum first and then taking the modulus. Similarly, if you are trying to calculate the negative value, modulus of A minus modulus of B, this is less than or equal to modulus of A minus B. Similarly, if you are taking the product modulus will not matter whether you take it before or whether you take it after. That is, modulus of A into modulus of B is actually equal to modulus of A into B. Because now even if one of them is negative, the overall product might be negative, but because you are applying the modulus, it becomes the same. Just to understand this better, let us assume that A is equal to 7. And B is equal to minus 6. That is, one of them is positive, one of them is negative. Then A into B will be minus 42. And modulus of this will be 42. Modulus of A will be 7. Modulus of B is 6. Again, the product is 42. So whether you apply the modulus before or whether you apply the modulus later will not matter in terms of product. So remember these 3 formulas and try to understand them intuitively so that you can answer these questions faster. Similarly, if you are given an inequality in modulus, which says that modulus of x is less than or equal to k, where k is a positive number, it would imply that x will lie between k and minus k. For example, if you are told that modulus of x is less than or equal to 5, this would imply that x has to lie between 5 and minus 5. On the other hand, if you are told that modulus of x is greater than or equal to k, then x will not lie between minus k and plus k. That is, either x is less than minus k or x is greater than k. It will not lie between minus k and plus k. That is, in this particular example, if you are told that modulus of x is actually greater than or equal to 5, then x will not lie between minus 5 and plus 5. It would imply that x is either less than minus 5 or x is greater than 5. If you are looking at a number line, here you have minus 10, here you have minus 5, here you have 0, here you have 5, here you have 10. Between minus 5 and plus 5, the value of modulus of x is less than 5. To the left of minus 5 and to the right of 5, the value of modulus of x is greater than 5. Just remember this, it will be easy for you to understand. Similarly, for any real number, the value of a square is equal to the value of modulus of a whole square. Because a square is positive, modulus of a whole square is also positive. that is minus 5 whole square, we are essentially saying is equal to modulus of minus 5 whole square, because modulus of minus 5 is equal to plus 5. The value of 5 square is equal to the value of minus 5 square. So the square of any number is equal to the square of its modulus. These are all the important formulas as far as modulus is concerned. If you are having any doubts, you can watch this video again. Let us answer 4 questions so that you can understand this formula better. In this question, we are asked to calculate the number of integer values of x such that modulus of x minus 4 minus 5 is greater than 2 when x lies between minus 11 and plus 11. Let us try to understand this inequality. Here you are given a modulus of an expression, we are told is greater than 2. This would imply that either the expression is less than minus 2 or the expression is greater than 2. That is, we either want modulus of x minus 4 minus 5 to be less than minus 2, or we want modulus of x minus 4 minus 5 to be greater than 2. That is, we want modulus of x minus 4 to be less than 3 or modulus of x minus 4 to be greater than 7. If modulus of x minus 4 is less than 3, either x minus 4 will lie between 3 and minus 3. Because if you are told that modulus of an expression is less than 3, it would imply that that expression will lie between 3 and minus 3. Whenever it is less than, it will lie between minus 3 and plus 3. If it is greater than, it will not lie between minus 2 and plus 2. Remember that. So in this particular case, we are told that either x, the boundaries for x are 7 and 1. Or when you have modulus of x minus 4 to be greater than 7, x minus 4 is either less than minus 7 or x minus 4 is greater than 7. Because remember that if modulus of x is greater than k, that expression is either less than minus k or it is greater than k. In this particular case, it would imply that either x is less than minus 3 or x is greater than 11. So the 3 intervals for x which satisfy this given inequality are either x lies between 1 and 7, or x is less than minus 3, or x is greater than 11. But we also know that x is an integer and x lies between minus 11 and plus 11, both of them included. So the values that x can take in this particular case are 2, 3, 4, 5 and 6. In this case, the values x can take are minus 11, minus 10, minus 9, minus 8, minus 7, minus 6, minus 5 and minus 4. In this case, x is greater than 11, so no values exist such that x will lie between minus 11 and plus 11. The total is, here there are 8 values, here there are 5 values. So the total is 8 plus 5, which is 13. So the answer for this question is 13. Let us answer another question. Here we are asked to calculate the number of integer values, integral values of x such that modulus of log of x square by 2 to the base 2 is less than or equal to 1. If you are given an expression and if you are told that this is less than or equal to a number k, if it is less than, it would imply that this expression will lie between minus k and plus k. So in this particular case, log of x square divided by 2 to the base 2 will lie between minus 1 and plus 1. The base of the logarithm is 2, which is greater than 1. So if you are removing the logarithm, the argument, that is x square by 2, has to lie between 2 to the power minus 1 and 2 to the power 1. 2 to the power minus 1 is 1 by 2. 2 to the power 1 is 2. This would imply that x square has to lie between 1 and 4. X also has to be an integer. So the integer values that x can take are, if it is positive, 1 or 2, if it is negative, minus 1 or minus 2. So the total number of integer values that x can take are equal to 4. Let us look at the next question. How many integral solutions are possible for the inequality? Modulus of x plus 8 minus modulus of x minus 4 is less than 2. If you know that there is an expression e which is less than a number k, it would imply that e will lie between minus k and plus k. So in this particular case, we want modulus of x plus 8 minus modulus of x minus 4 to lie between 2 and minus 2. We have removed the outer modulus. Now to remove this inner modulus, we need to have an idea about where the value of x will be. There are two inflection points over here. This is when x is equal to 4 and this is when x is equal to -8. So let us consider the three cases where x is less than -8, then -8 is less than or equal to x is less than or equal to 4, and finally when x is greater than 4. When x is greater than 4, modulus of x minus 4 is x minus 4, modulus of x plus 8 is x plus 8. So this given expression will be x plus 8 minus x minus 4. This is equal to 12. Does this lie between 2 and -2? It does not. Now what will happen if x is less than -8? If x is less than -8, x plus 8 will be minus x minus 8 minus of, what is modulus of x minus 4? This will be 4 minus 6. If you are simplifying this, this will be -12. Does this lie between -2 and +2? It does not. So no values of x exist. Suppose x lies between -8 and 4. What is the value of modulus of x plus 8? That will be x plus 8. What is the value of modulus of x minus 4? That will be 4 minus 6. So this is equal to 2x minus 4. 2x minus 4 is 2 times x minus 2. We know that x is a integer. We are only looking for integral solutions. And this expression has to lie between -2 and +2. X minus 2 will be an integer. So 2 times x minus 2 will also be an integer. Now if 2 times x minus 2 is an integer, which is an even integer, which lies between -2 and +2, this has to equal 0. Because the only integer between -2 and 2 is 0. This expression has to be either -1 or 0 or 1. If it is -1, we will have no solutions which are integers. If it is 1, we will have no solutions which are integers. There will be an integral solution only if this is equal to 0, in which case x will be equal to 2. So the number of integral solutions is exactly equal to 1, which is option B. Let us look at one more question. What is the range of values of x which satisfy the given inequality? Modulus of x minus 2 into modulus of x minus 2 into x plus 5 is greater than 0. If you are looking at it, the first thing you can notice or you can confirm is that x cannot be equal to -2 or 2 or -5, because in all of these cases this expression will be equal to 0, and when x is not equal to 2, modulus of x minus 2 is always greater than 0. So this middle term is always positive, so we can kind of ignore it in this product. What we are essentially looking for is modulus of x minus 2 into x plus 5. We want this to be greater than 0 because this term is always positive. So if we are looking for a product which is greater than 0, if we know that that number is multiplied by a positive number, it will always be greater than 0. So we can ignore it. So out of this product, modulus of x minus 2 into x plus 5, if this has to be greater than 0, there are two cases that are possible. Either both are negative or both are positive. Let us first look at the case where both of them are negative. In that case, modulus of x minus 2 is less than 0 and x plus 5 is less than 0. So modulus of x is less than 2, or x lies between -2 and +2, and we want x to be less than -5. So we want x to be less than -5 and we want x to lie between -2 and +2. This will not happen simultaneously. That is, both of them will not be negative at the same time. So this case doesn't exist. Let us look at the other case where both of them are positive. So we want modulus of x minus 2 to be greater than 0 and we want x plus 5 to be greater than 0. So we want modulus of x to be greater than 2 and we want x to be greater than -5. If modulus of x is greater than 2, x is either less than -2 or x is greater than 2, and we want x to be greater than -5. So we want x to be greater than -5. We also want x to be either less than -2 or greater than 2. So the values that x can take lie between -5 to -2 and 2 to infinity. Basically, x is greater than -5 and x cannot lie between -2 and +2. These are the values that x can take. If you are looking at the options, the correct option is option C.